So moving up to the next, we discuss about different types of bacteria, that is either aerobes, anaerobes, or facultative anaerobes, etc. So the very first one is anaerobes. So anaerobes, we can see here that is anaerobes can't breathe fresh air. It means O2 is not necessary for anaerobes. Examples includes that is bacterioids, Clostridium bacterioids, Fusobacteriums, Actinomyces israeli. They lack catalyzed and or superoxide dismutase. They lack catalyzed and superoxide dismutase and are thus susceptible to oxidative damage. This okay now anaerobes are normal microbiota in GI tract, typically pathogenic elsewhere. So anaerobes are normal microbiota in GI tract, but except the GI tracts they are pathogenic. Now aminoglycosides, that is aminoglycosides are ineffective against anaerobes because these antibiotics require O2 to enter inside the bacterial cells. So as anaerobes are does not require O2, uh, but aminoglycosides are ineffective against anaerobes. Now generally foul smell or short fatty chains acids are difficult to culture and produce gas in tissue, that is CO2 Now talking about the facultative anaerobes, so anaerobes are generally those which does not requires O2. But what about facultative anaerobes? So it may use O2 as a terminal electron acceptors to generate ATP, but can also use fermentations and other O2 independent pathway. So they generally they are in anaerobes, means they does not require O2, but if O2 are present they may use O2 also, so they are known as facultative anaerobes. So streptococci or staphylococci and enteric gram negative bacteria. Now talking about the intracellular bacteria, we came to know about obligate intracellular, that examples is rickettsia, chlamydia, coxiella. Stay inside cells when it's really chilly and cold. So obligate intracellular examples given, that is rickettsia, chlamydia and coxiella rely on hot ATP. Now talking about facultative intracellular examples is Salmonella, Neisseria, Brucella, Mycobacteriums, Listeria, Francisella, Legionella, Yersinia pestis. And here mnemonics is given. Some nasty bugs may live facultatively. So facultative intracellular Salmonella, Neisseria, Brucella, Mycobacteriums, Listeria, Francisella, Legionella, Yersinia pestis. Now talking about the encapsulated bacteria. Examples are Pseudomonas aeruginosa, encapsulated bacteria, and mnemonics given here, that is please sign my skies. So examples are Pseudomonas aeruginosa, Streptococcus pneumoniae, Haemophilus influenza, Neisseria meningitis, Escherichia coli, Salmonella, Klebsiella pneumoniae, and Group B straps. These capsules serves as antiphagocytic virulence factors. Capsular polysaccharides, that is plus protein conjugate, can serve as an antigens in vaccines. Polysaccharide antigens alone cannot be presented to T cells, and immunogenicity can be enhanced by conjugating capsule antigens to carrier proteins. Here are opsonized, so encapsulated bacteria are opsonized and then cleared by spleen. A splenic, no spleen here, so have decreased opsonizations ability and thus increase risk for severe infections, need vaccines to protect against Neisseria meningitis, pneumoniae, and influenza, influenza. Now talking about the urease positive organisms, the mnemonics is like P chunks, so protease, then cryptococcus, H pylori, urea plasma, nocardia, klebsiella, and S epidermis, yes, saprophyticus. Urease hydrolyzes urea, so urease hydrolyzes urea to release ammonia and CO2. Increased pH predisposes to struvite magnesiums, ammonium phosphates, stones, particularly protease. So magnesiums, ammonium phosphate, stones are seen particularly in protease, that is protease. Okay.